Hi, Year 10, and welcome to Space, which is where I'm living now, apparently. This is our next lesson about electrostatics and static charge, and particularly how we have safety features built into electrical things around our house and here in space as well, obviously. I'm going to share my screen quickly and talk you through the task, but actually a lot of the work you're doing today will be stuff you're doing independently anyway, but I just wanted to quickly check in with you, see how you're getting on, and quickly talk you through the task you're going to be doing today. So if I share my screen, we should be able to get that going there. There we go. Okay, so like I say, it is mostly about electrical safety today. Now, in the assignment, in the task, you'll see you've been sent some instructions, and your instructions today are about making a single-page presentation that explains the main ways that electrical devices are kept safe around our home. Now, you can choose to do that in any single-page format that you want. If you want to submit me a Word document, if you want to draw and make your own presentation at home and send me a poster, if it's a single slide presentation of PowerPoint or Google Slides, whatever format you want, as long as it fits onto a single page. That page can be as big as you want if you've got some super duper big bits of paper lying around, or it can be anything you want as long as it fits on one single page that you can upload to me or send me a photograph on. And the main electrical safety features around our houses are fuses, earthing using the earth wires, and circuit breakers. So I just wanted to quickly run through some of the theory on that, but I've also posted a link on the assignment, which will take you to a page which has some pretty good information about the main electrical safety features around your house: fuses, earthing, and circuit breakers. So first thing I want to talk about then is earthing. Let me get my little presentation up here. Okay, earth wires. So how does an earth wire help to keep us safe? Well, first of all, one thing to point out is we only have earth wires on devices which are metal cased on the outside. In other words, they could become live. Electrical current could flow through them and give you a shock. Now, normally around our house, if we think about the wires inside a plug, we've got our live wire, carries the current in. The current would flow through my toaster here. Current flows back out through the neutral wire. So those two wires normally complete the circuit. That toaster will work just fine with a live wire and a neutral wire. So why do we have a third earth wire in a plug? Well, the earth wire is a safety feature, and the earth wire helps us out if a fault develops inside the toaster, and a fault where that live wire is somehow touching or has come in contact with the metal casing. Because now if that live wire has touched the metal casing, the current is flowing through that metal casing, and if we were to touch it, current would flow through us and give us an electric shock. So how does the earth wire help us out there? Well, the earth wire, that third wire, is actually connected directly to the metal casing. So any current that flows through the metal casing will actually flow out easily down through the earth wire. And that earth wire is plugged into the ground outside the building. If you could follow the earth wires from your plugs and rip out the wires from your walls, you would find that somewhere outside your house there is an earthing point, or a point where the earth wires are connected into the ground. So that current would flow very easily through the earth wire down into the ground, so it doesn't flow through you. But the other advantage of this also involves the fuse. Because the resistance of the metal case is very low, current can flow through it easily. If the current flows through that metal case, a very large current flows through the metal case and down through the earth wire. Now, a large current will melt the wire inside the fuse in the plug. Breaking that wire breaks the circuit, and so that means no current flows through the appliance any longer. So a combination of earth wires and fuses is one of the main ways we can keep electrical devices safe around our house. Now, the other one I've mentioned, just to give you a quick overview, is what's called circuit breakers. You may well know around your house somewhere where there are things you might call a trip switch or a fuse box around your house. Chances are they are now what we call circuit breakers, or properly residual current circuit breakers, which protect us from too much current flowing through devices. Now, they work a bit differently from fuses. If too much current flows through a fuse, the wire inside that fuse melts and it breaks the circuit. Residual current circuit breakers are connected to the live and neutral wires. Now, there should be the same amount of current flowing in through the live wire and out through the neutral wire. If that isn't the case, the current circuit breakers detect that difference between the live and the neutral wire, because that suggests there must be a problem. Current must be escaping somewhere, and the circuit breaker, the switch on it flicks, and that shuts off the current. Now, that's a big advantage. First of all, because it's a switch breaking the circuit, you can reset the circuit breaker and use it again. It's not like a fuse where the wire has melted and you need to put a new fuse back in. It's also a lot more sensitive than a fuse. The difference between the live and neutral wire that it can detect is very, very small. So it's a lot more sensitive and it's a lot quicker to respond than a fuse. Now, in terms of how a circuit breaker works, on a very simple level, I've just quickly nicked this diagram off a YouTube video. One simple way of thinking about it is that it's basically an electromagnet inside the box. If too much current flows through that wire, if the current increases in this wire around the electromagnet, it makes this electromagnet stronger, and that pulls this switch towards it. That's the switch which disconnects the circuit. So that explains why it can be reset again, because I just need to push the button and reset that switch. So it works by using the principle of electromagnets. Okay, so those are the main sort of ideas in terms of our different electrical safety features to protect you around the house. You're now semi-experts on that. Go make yourself experts. Use that link that I provided you, and of course the other research you'll do, to make that single sheet presentation which summarizes the use of fuses, the use of earth wires, and the use of circuit breakers to keep our electrical devices around the home safe. Double check the instructions on the sheets. There are some good guidelines about what your presentation should look like. And please remember to submit that work so I can give you a bit of feedback on it. Please leave me any comments or any questions on Google Classrooms so I can catch up with them. Otherwise, if you need me, you know where I'll be, here in space, and leave me any comments that you need. See you soon.